scientists have prepared the galvanic cell by taking the concept of the redox reaction. So to prepare the electrochemical cell or the galvanic cell, we have to take two separate beakers here. In one beaker, they have taken zinc sulfate solution, say 1 molar zinc sulfate solution. Okay? And in another beaker, an equivalent amount of copper sulfate solution was taken. In first beaker, they have dipped a zinc electrode. That is our zinc rod. So we can say zinc electrode or a zinc rod is dipped in zinc sulfate solution. But in the previous redox reaction, what we have said, the zinc electrode was dipped in weight, that was dipped in copper sulfate solution. The phenomena remain the same, but little bit difference is here. See, what phenomena remains the same? When the zinc electrode is dipped in zinc sulfate solution, same phenomena we are going to get here. The zinc atom from the zinc electrode will oxidize to what? Zircon to positive ion. And this electron released will accumulate at the electron. In the previous case also we have said, this electron in the previous case, what we have studied? That this electron was gained by what? That was gained by the Cu2 positive ion present in the solution. But in this solution, no Cu2 positive ion is present. Then what they thought? Yes, if they want to gain, if this copper ion is supposed to gain the electron, then this electron should move through certain conducting wave. Correct? This electron, because the copper sulfate is present here, and here we are having this Cu2 positive ion now, not in its own cell. So this electron released will migrate through a conducting wave. So in that case, what they have done? They have placed a copper electrode in copper sulfate solution. Got it? Then the two electrodes are connected with the help of a conducting wave through an electrical appliance. The electrical appliance, that is like a bulb or voltmeter or galvanometer, any electrical appliance you can take it here. Now see, this electrical appliance, suppose that we have taken the bulb here. Then what is going to happen? This is the construction portion actually. This is the construction portion of our galvanic cell. So how this galvanic, what is the construction portion? In the construction portion, what we have seen? The zinc electrode is dipped in zinc sulfate solution and the copper electrode is dipped in copper sulfate solution. Now see, what is observed? What observations they have recorded? The observation is that when zinc electrode is dipped in zinc sulfate solution, the zinc atom present in the zinc electrode is oxidized to Zn2 positive ion, and that Zn2 positive ion will move into the solution, and this released electron will migrate through the copper wave or any conducting wave. When the electrons move through the conducting wave, there will be glow of light in the bulb. The bulb glows. It indicates what? The bulb glows means what is going to happen? There is production of electric current. We know that these electrons are moving towards this plane. This is our, say, copper rod or copper electrode. Towards the copper electrode or copper rod. Then what is going to happen? Here we are having the electrons that is coming out for the conducting wave. Cu2 positive ion will move towards the copper electrode. Since Cu2 positive ion moves towards the copper electrode, it is supposed to gain the electron used by the zinc atom. Now suppose the zinc atom is losing 2 electrons. So it will gain 2 electrons and gets converted into or reduced into copper atom. And this copper atom will deposit at this copper electrode. So what is going to happen? Here we will find that the copper electrode, what is going to happen? That is gains weight, whereas the zinc electrode, since zinc atom is oxidized to Zn2 positive ion, zinc atom loses the weight. So another observation made is zinc electrode loses weight. Up to this much clear to you people? Now see, further when we say loss of electron means that is our oxidation, half radiation. Gain of electron means reduction, half radiation. Now see, already we have studied that the electrode where oxidation occurs. In which cell the oxidation is occurring? Left hand side cell. So simply we can say that oxidation occurs at the left hand side cell. Oxidation occurs at anode. Always remember that oxidation will occur at anode. This is the phenomena which is known as oxidation reaction and it should occur at anode. So this electrode is our anode. Clear? This anode is what in charge. Now see, when the zinc atom loses the electron, this electrons will be deposited first in this electrode. So this electrode will be negatively charged. So the anode will be our negative terminal. Please make the terminology very clear. So why it is negative? The anode is the first concept is that why this electrode is considered as anode? Because here oxidation is occurring. Oxidation occurs at anode, and the anode terminal is considered as a negative terminal. Why negative terminal? Because of the fact that zinc atom what is doing loses the electron. This electrons will be present at this electrode, so this electrode is the negative electrode. If this is the negative electrode, automatically here CO2 positive ion is going. This is our positive terminal. Now see, at the positive terminal in the right hand side cell, what is occurring? Reduction occurs. Please note it down. Reduction occurs where? At right hand side cell. So already we know that reduction occurs at which electrode? That is at cathode. And our cathode is the what terminal? The cathode is our positive terminal. So please remember that in the galvanic cell, the anode is the negative terminal. At anode oxidation occurs. Cathode is our positive terminal. This is our cathode. Cathode is our positive terminal. At cathode, what occurs? Reduction occurs. Clear? Now see. Yes, by using the concept of the redox reaction. What is the main principle behind that? The redox reaction. Yes, due to this redox reaction of flow of electron transfer, what we find there is flow in the electric bulb. But this flow of light is for a very limited period of time. There is flow in the electric bulb for 3 to 4 minutes. And after that the working of the cell stops and the glow of light ceases. Got it? So this glow of light is observed by the scientist only for 3 or 4 minutes and after that the glow of light ceases. Means what? The functioning of the cell stops. Then what came in the mind of the scientist? They thought that if it is like this, means there is certain defect in that cell and that defect should be modified. Got it? So first, what is the defect in the cell? Yes, redox reaction is going on, electron transfer is also there, glow of light is also there, but it is for a limited period. So it came into the mind of the scientist that there is some defect. So first we are supposed to study what is the defect present in this cell. And as a result of it, the functioning of the galvanic cell is for a very limited period of time. Now come to the defects. Let us study the defects occurring in this particular cell. Very simple concept. The defect is also very simple to understand. Now see, when the cell is in the working condition, initially what we have? We have the concentration of Zn2 positive ion in this solution is equal to the concentration of SO4 to negative ion. That is initially. Clear? Yes or no? When the cell was not working or not functioning, here also the concentration here I am showing you the concentration of what? Cu2 positive ion is equal to the concentration of SO4 to negative ion. Yes or no? Yes. But when the cell starts working, what happens? concentration of Zn2 positive ion is greater than the concentration of SO4 to negative ion. So during working condition. During working. It is clear? This is because of the fact that the zinc atom from the zinc electrode is oxidized to Zn2 positive ion and it moves into the solution. So the concentration of Zn2 positive ion in the solution increases. Clear? And in this case what is happening? See, from the solution the Cu2 positive ion is moving here and it gets deposited. Means the concentration of Cu2 positive ion is decreasing. That is less than the concentration of SO4 to negative ion present in the solution. Then usually what happens? If this solution is become rich in the concentration of Zn2 positive ion, means this solution becomes what in nature? That is a positively charged solution. Positively charged solution. Clear? This solution becomes positively charged and this solution becomes negatively charged. Clear? This solution becomes positively charged now and during the working condition of the sun, this solution becomes positively charged and this solution becomes negatively charged. If the solution becomes positive charge, this is the main difference. What is going to happen? Yes, we will be having the positive charge here. It means what? The solution is positively charged. If the solution is positively charged, means what is going to happen? The positive charge will accumulate around the anode. And if it accumulates around the anode, then what is going to happen? Here, zinc atom loses electron. This electron is liberated by the zinc atom, whether it will be allowed by the positive charge to migrate through the conducting wave? Definitely no. Because the positive charge is having the affinity for the negative charge. So this positive charge, since the solution is positively charged, this positive charge will have the tendency to pull the released electron towards itself. And as a result of which the migration of electron through the conducting wave will be difficult. If in case one or two electron moves through the conducting wave also, and if it reaches this electron, then what is going to happen? Here this solution is reaching what charge? This is reaching negative charge. Since this solution is reaching negative charge, then what is going to happen? This will repel the electrons. This charge will repel the incoming electrons. Whether the part is clear to you, but this charge will be repelled by the what? The incoming electron will be repelled by the negatively charged solution. Clear about the point? Now this is the defect. So what is it? If it is like this, then what is going to happen? The electrical neutrality of the solution will not be maintained. The main problem here is that since the electrical neutrality of the solution is not maintained, then what is going to happen? The flow of electron becomes difficult. Clear? So when we say the defects, what is the defect? The solution, as when the cell is in the working condition, the solution becomes positively charged. Clear about the point? Since the solution is positively charged, it will attract the negative electrons present in the electrode. Where from these negative electrons are coming? The zinc atom is releasing the electrons. So that will be attracted and the flow of electron will be ceases. Clear about the concept? Then this is the defect. Clear about the defect? Please note it down. Now after that we are going to study how this defect is overcome. This defect was finally overcome